Hi, I'm John Moore with JHM Technologies. Here today, let's talk about our different molding processes common to the low-pressure closed molding industry. Now, often we hear these acronyms and we immediately think that there's something unique about them, but let's just talk about that. We have Light RTM, RTM, VIP, or vacuum infusion, and of course accompanying that in that process is the reusable silicone bags. So within that, there's a variety of giving it acronyms inside of it. But it basically comes down to, in effect, two methods. One here where we have two rigid mold halves. Here with a vacuum infusion process where we have a lower mold half, commonly it's the low mold, and we have fiber and then some form of film, either just a simple nylon film that's sealed with butyl tape around the perimeter flange, or a reusable silicone bag that too is sealed around the flange, but in that case with vacuum itself holding that flange of the silicone bag down tight. Now, today we're told, well, the one processes are interchangeable, or the things are all the same and it's just different ways to do it. Well, the truth of the matter is, if you're a molder, these are different tools, different process methods that achieve similar goals, but not always the same. There's a reason we choose one method over another. Sometimes it's productivity. Sometimes it's fiber content we're looking for. Sometimes it's die locked, and we'll have some examples of that. So what we're going to do is we're going to quickly talk about what is the difference you get out of the mold, and then we'll take a look at a few molds here over the next couple days as they come off the line. So first off, light RTM, RTM, in effect is the same thing. We could have even said high pressure RTM, HP-RTM over here as well, where we could, if we're going to, we could gel coat the mold surface, typically the A side. We may even want to gel coat the B side. That's fine. We can do that with two rigid mold halves. The difference here though is the part thickness is going to represent what the mold was made to. In other words, we calibrate the mold to a given part thickness, and that locks that part thickness in there forward. Now the difference is there in the vacuum infusion process. We have one mold half, we line it with fiber, dry, bring a bag, one form or another over the top of that, and then pull full vacuum down and pack that fiber tight against the mold surface. Then we infuse the resin in, either simply by differential pressure, vacuum having drawn all the atmosphere as much as we can out of the mold cavity under the film, and then a bucket, simply as it were, and a tube, and the atmosphere is pushing the resin into the mold. Never do we want to think that vacuum is actually sucking it in. It's actually the outside atmosphere pushing it in. But you could even take that a step further. You could take the bucket away, connect an injection equipment, meter mix equipment to it, and inject it in on a controlled fashion and somewhat accelerate that infusion speed. But back here to the light RTM, most commonly we are always pumping it in. We're pumping it in, as we said, to a fixed part cavity thickness, having loaded the mold, closed it with dry fiber in. So let's take an example. Here we have gel coated, exact same gel coat, exact same resin, exact same fiber. One was made in the RTM process, one was made in the vacuum infusion process. What's the most obvious difference? Well, let's take the vacuum infusion process. The first thing is smooth surface, and we could be somewhat arbitrary and say, well, it's got this surface, that surface. Let's just say the surfaces are representative of each other. The backside, well, it's smoother than open mold, but it's still got some irregularity to it, but probably good enough for many applications. But here's the big difference. Look at the flexibility, okay? Same fiber load as far as same fiber. Now that's just it. The fiber loading is higher. Resin content is lower here, but we gave up thickness. Here, same fiber, same resin, just more resin because we've done this in a fixed cavity. Yes, smooth backside. In fact, it could even be gel coated and you'd have in effect two sides of equal quality. The big difference though is that stiffness. In most parts, the concerning factor is how stiff and rigid they are, so they're not warping and waving as whatever their application is for. We're going to show you the back end of an RV. In that case, you got this large 7-foot by 8-foot wide panel. If it's done in the vacuum infusion process, unless we add more material and bulk it up, which is more expensive than the resin change, but if we left it as it were, the back end of that motorhome would just oil can. But it's made just like this, light RTM. Now, again, there's nothing wrong with one process over another. Just understand they don't produce the same product. So we have to make logical choices in our process methods. Here at JHM Technologies, we build a variety of molds. We build light RTM, what one's called RTM because it's more of a high pressure forcing it in, but in effect it's the same thing. Quite honestly, it's all RTM. We build vacuum infusion tools, and we build high pressure RTM tools in that limited fashion and the varieties that are here. But with the local automotive industry, we're getting more and more involved in that. The point is, we here have no reason to be subjective to one over the other, except we pull the right tool out of our toolbox when the customer comes to us with an application. So let's take a look at some molds and give you the insight you need to make the right choice in your molding operation over the process you choose. In this case, we chose an RTM Light mold. It's the rear cap of an RV, the whole rear end of the RV as it were. We have the tail lights would be installed in the back of this, and then that whole back would appear like a window, but they usually leave it blocked in. So in this type of tool, we have two rigid halves, right? So that gives us a fixed cavity. In this case, it's 3/16 or 188 thousandths. In this area between the outer perimeter seal, that seal comes all the way around the mold, that lip seal here, and then the resin seal here. This distance between them all the way around is held down under vacuum. So we pull full vacuum in this area, clamping the tool together. Now the whole cavity area, that's under a regulated level of vacuum, roughly a half a bar or about 15 inches. When we inject here, and what you may not be able to see in the video though is there's a resin channel that circumvents all the way around the part. So we're asking the resin to racetrack around the part. And what I'm sure you can't see in that video though, but I'll tell you is there, this surface right here, just outside the resin channel, is designed to have a very specific gap with a mold flange below. That way the resin's flowing all the way around and it's leaking between that gap, giving us a very uniform fill. And we fill to the vents in the center. In this case we have two, most commonly we have one, but in this case we have two vents right in the very center of the part. So the resin's coming in all the way around and then converging to the center. Now why did we choose RTM Light for this part? Think of it again, it's the back of the motorhome. You can't have it flexing and blowing like oil canning on the back end. It needs some stiffness. If we had used a silicone bag, which would have been the alternative, then the bag, by the fact it's under full vacuum, would have compressed the fiber down tightly, and we'd have, like I've shown you in the classroom, a much thinner laminate, unless we spend a lot more money on bulking materials. So yes, we have a higher resin content than we would have if we had the bag, no argument, but to get the stiffness that we need so that stays stationary on the back of the RV without oil canning, we used the same amount of fiber to get us at around 25 to 30% by weight, but we're able to achieve the resin to ratio levels by a fixed cavity of 188 thousandths. So let's take a look at the part. This is an example of the part. Now bear in mind this part is painted. So this is a primer gel surface. It's known that it's going to be sanded. So it isn't that high gloss wet look we would get with a true exterior gel coat, but it's perfectly suitable for the application because it is pit free, print free and such, so that it's easily painted. But the point of it is it's stiff. Now there's nothing behind it. So we've got that stiffness on the back of the motorhome. Now it's going to stay stationary. You come up and you feel that, you're going to feel there's quality in the motorhome. If that whole back end's oil canning, well then it's going to have the perception of a weak vessel. So in this particular case, RTM Light made a lot of sense. And productivity-wise, one operator with an intermittent assistant helping them should easily get 4 to 5 of these out of the tool set working at ambient temperatures. Now if we move into heated tools and advancing the process, we can get greater than that. But 4 to 5 parts should be expected. It's not too bad a productivity, and in this case they're looking at about 1,000 a year. It was a very good fit for light RTM. We've talked about light RTM, and we showed the example earlier of the rear end of the RV. Now we're going to dip into our toolbox again and try a different tool as a molder. And why would we do that? Well, again, we look at our products. We look at our, okay, the production we need, that's one thing. But often we're running into problems, and those kind of problems often are the geometry. In this case, it's die-locked. This is a bumper is again on an RV actually, and in this case, the bumper on each end has these details for styling. But if you envision the mold, which this is the half of the mold there, up against here, we wouldn't be able to lift the part out because it's locked here. And in fact, if we got deeper into the geometry, you'd realize it's even die-locked down into some of the other areas of the part details and shape. So what did we do? We built a mold with a flange. That's not new to us. But things that are new are sealing around that flange. Many have tried that. And sure, it's easy enough to run everything from an O-ring to a wing seal around that flange and seal around the length of the flange. But where the issue comes is right at the end, right when the seal comes up and it intersects with this seam line. There's where you always have a leak. And we have solved that. We have had a way now to interact the silicone bag, as we're going to show you here in a moment, interact with that seal that's circumventing the flange. And that's a key to locking this in. But again, we chose the vacuum infusion process not as a replacement for RTM part for part. It's a replacement tool in our box for the Light RTM because of the geometry. We can have a mold that splits apart, and in a Light RTM we would have the upper split. Well, that's not practical. So here it is. Cavities pulls apart just like an open mold application. But give us a minute here, and then we'll pull this part out, put this back together. We'll show you how the bag interacts with the mold. We'd put the bag back in place, took the part out of the mold, and we put the flange back in place. So we, in effect, have one constant mold surface. Remember, we have a seal circumventing around that flange, right? And then the way it terminates here at the end matches up with these protrusions on the silicone bag. And that's the trick to getting that bag to seal up. See, you'll see many applications out there using a sprayed-on silicone bag with various means to get the bag to seal around the perimeter, because that is the key to this process success. And what we found to be the best, this is not our design, this is Swirl, Prairie Technologies, the V-groove in the mold flange and then building that groove protrusion into the bag. And this protrusion is not quite as long as the groove is deep. So there ends up being a vacuum drawn under this. So the vacuum is running around under that protrusion, pulling it down like a cork in a bottle. And then we've taken it to another level, the way we've interacted with the seal on the edges. Now the next problem that you have with the vacuum infusion process is dispersing the resin. There's a rule of thumb that we can come in to a point, because in this type of process we're normally working with a diverging flow path. So unlike the RTM Light mold we showed you on the rear end, in this case we're injecting into the center of the part and dispersing the resin away from that ejection point. Typically you don't go beyond, say, 30 inches of travel. So how do you get it out there? Well, we don't want to be putting breather film or flow medias or what have you in here. We want to have a means to direct it. So we have a resin channel, which I'm going to show you just how that works, because this channel lifts up, allows the resin to flow, and then you take the vacuum away that's drawing it up and it lays back flat again, so you don't have that channel in the part, which would be an interesting point if you had a resin-rich channel on an A surface part. That area could tend to shrink back and show on the A surface. So let me explain again what I'm talking about. Remember, we're talking about this resin channel injecting in the center and the resin dispersing to both sides of this part length. So we've done that, having that channel. Now, I've flipped the bag over obviously, and we're looking along this line. It's right down the center of the part. And you see, you don't see any sort of line there now. Well, let me turn the vacuum on. Now you see this groove appear. When this bag is placed down in mold position, again, we've got gel coat in the mold, we've got dry fiber in the mold, we've got tabs coming up for venting using you can use various things, but we typically will use a type of veil. We'll just bring the veil up, and that communicates to a perimeter. That's what this vacuum port is, a perimeter channel of vacuum. That's your exit or venting vacuum, injecting in the center. And that groove I showed you that appeared from the vacuum on this channel, which is applied on top of the bag, right? That allows the resin to come in, flow out, it'll flow across, and all those tabs will communicate to this perimeter, and that'll be how the cavity or the resin will flow out and the cavity vacuum will be evacuated through that area. So let me just show you that one more time because it's a lot to take in all at once. So again, here's that groove that appeared in the bag caused by the vacuum. If I take that vacuum away, see, the groove goes away. So our flow channel is there when we need it. We take the vacuum away, it flattens back out so the back side of the part is smooth and doesn't have that channel in it. All right, we chose vacuum infusion in this case because of the die-locked ends. Not practical to build an upper that comes apart. All right, let's get another example. Now we've got one more part to look at. Again, we're thinking as a molder, what shall we choose? Is it light RTM? Is it SMC? Is it vacuum infusion? Do we do it with disposable bagging film or do we use a reusable bag? Well, if we have any type of production at all and we're looking at vacuum infusion, we're definitely going to look at a reusable bag. And silicone bags are proven to be the bag of choice. So we've got here again another part that when we looked at it, we said, well, there's no way that we can do that in two rigid molds because we've got a die lock here on this one end. And actually, this other surfaces lock as well. So here again, we chose vacuum infusion. Now remember I said to you that when we were talking about the bumper, we had those tabs. These are your venting tabs that come out. So there's a channel in the silicone bag that's drawing vacuum that circumvents the mold. And then you just put these tabs out. So this is where the vacuum's being drawn. In effect, it'd be like your vents on your mold if it were a light RTM mold. This is where the resin is being chased to. Now, we can look at that back side. You may not be able to see it in the video. Yes, it's smooth in comparison to rolled out chop and open mold, not a molded, shiny, smooth surface like you get in light RTM, but it's smooth. It's reasonably uniform. So it's an attractive option, especially when we have geometry like this. Now, on the bumper, we showed you that we removed flange. In fact, on the bumper, it's both sides are die locked, so both flange ends open up. In this case, we didn't want the complexity of that flange opening. So here, we've got a Delrin insert that is in the mold, this white piece here. Let me pull the bag out of the way so you can see that a little better. If you look here on the end, this white area is a machined Delrin insert. So that machined insert was laying on the pattern that we made this mold off of. So we had the Delrin insert on the pattern with fastening locations above, and we laminated the red mold over the top of the Delrin insert while sitting on the pattern. And then we were able to pop the mold off, leaving the insert, and then take the insert off so we could get it off the pattern because it would be die locked, right? Now, the insert being here, all we got to do is take two bolts out, pull the insert and the part right out. It takes care of the die lock issue, fits right back in like a glove. And so when we're molding, we didn't in this case need to cut the whole end off. We just needed this one area that's given us a serious problem for demolding. The rest of it we can flex and get out of the mold. Again, vacuum infusion using a reusable silicone bag was the right tool to grab in the box for this application. So we look part by part and take in consideration part geometry, uniform thickness concerns, smoothness on the backside concerns, our productivity concerns. We add all these factors up, and then that's the tool we select out of our molding box. That's the way we decide vacuum infusion, light RTM, or whatever method we're going to use to make the parts. Thanks.